Hi guys, as you might know, I am absent today, so I am going to do some notes on isotonic solution and hypertonic solutions today via this webcast. So please go ahead and go to your notebook and open up to the paper that we ended off on yesterday, which I believe is page 18 or 19. So it ended with water poisoning. Please go down here to where it says isotonic solutions. Okay. Iso means equal. And tonic means salt. So we're going to have equal salts on both sides of the membrane. So let's go here to our red blood cell. And as we know, red blood cells are 99.1% water, and whatever is not water is salt. So your red blood cells are 0.9% salt. Okay, so if it's an isotonic solution, you have to have equal water and salt concentration on both sides. So this surrounding solution would have to be 99.1% water and 0.9% salt. So what happens here is not the absence of water moving, but water moving in a dynamic equilibrium, which means it continues to move, but it continues to move back and forth in an equilibrium pattern. So equilibrium has been established as well as maintained. Okay, so this is isotonic, means equal salt concentrations on both sides of the cell membrane. I'll give you some time to write that down. Please feel free to pause. And when you are done writing down what an isotonic solution is, I want you to answer this question. What would happen if a hospital gave a patient an IV with distilled water in it? Okay, so some background information is that when you get an IV, if you've ever had an IV before, which is, it's very blurred out right here, but it's where you get a drip into your arm of liquids because you're dehydrated. If it's pure water, it's really bad, which is why the question is stated this way. It's supposed to be isotonic to your blood. So when you are getting an IV, you're actually pouring this concentration into your bloodstream. Why would it be bad to give someone distilled water in their IV instead of something that is 0.9% salt? Please pause and answer the question. Once you've answered this question, now it's time to move on to hypertonic solutions, our last type of solution. All right, so hypertonic means more. Hyper is that prefix that describes things that are just a little bit extra. Hyper. This is going to be more salt compared to the cell. So these are solutions with more salt compared to the cell. So similar to yesterday's class, we're going to diagram what the cell will look like before and after being placed in the hypertonic solution. Okay, so here's my red blood cell. It has 99.1% water, 0.9% salt, And because this is a hypertonic solution, the surrounding solution has to be saltier. Yesterday, we used the word in the notes that was kind of silly for hypotonic. It was waterier. Today is hypertonic, saltier. So my surrounding solution needs to have a higher salt concentration. So let's just up it to 2% salt. And whatever's not salt is always water. So I'll keep this at 98% water. Okay. So let's find our concentration gradient with water. Right here at 99.1% water, that is a higher water amount than the outside solution at 98. So water is going to flow from high to low. So water is going to exit this cell. As a result, this cell shrinks. So this is going to be the same color I used to highlight that cell I'm going to use over here to show my resulting cell. Okay. The result is that the cell shrinks, which is called plasmolysis, which is destruction of the cytoplasm. Cell shrinking. Compared to yesterday, when the cell bursts, it was called cytolysis. The opposite of that is plasmolysis, with water exiting the cell to equalize the water amount on both sides of the cell membrane. Okay, now, both plants and animals do not like to be in hypertonic solutions. They don't like these salty solutions. So for plants, it's going to be a negative, and for animals, also a negative. Okay, so I wanted to ask you some real-world questions about these solutions' effects on plants and animals. So please answer these questions. If a bowl of fresh strawberries is sprinkled with sugar, so the sugar is our salt, a few minutes later, the berries will be covered with juice. Why is that? Pause and answer. Next question. We've always had these pesky slugs when I grew up in Oregon on our porch when we woke up in the morning. And my mom always said, oh, just pour some salt on it. It will kill it. Like, oh, that doesn't make sense, but okay, Mom. So I want you to explain why does pouring salt on a slug kill it, okay? And it dies because of what's happening to its cells. Pause and answer. Now, down here, this is a famous quote from the Rime of the Ancient Mariner. There were these stranded sailors out at sea, and they were frustrated. They were going to die of thirst, and they said, there's water, water everywhere, but not a drop to drink. This is a famous line in the Rime of the Ancient Mariner. Thirsty sailors were surrounded with ocean water, but still did not have any water to drink. Please explain why they could not drink the salt water and survive at the same time. Please pause and answer. Now, at this point in the class period, you should have these notes done. You should have the gummy bear math done up through percent change in mass. We will do this analysis and graphing on Monday in class. When you are done with the math of the gummy bears and you've thrown away your cups and your gummy bear, just don't throw away the Weibo cup, then I want you to do the assignment on Edpuzzle, the Amoeba Sisters on Osmosis. So I will post on my Haiku your class code. You must log in to the correct class. I hope you guys have a great weekend, and I'll see you Monday.